Hello, my name is Jean de Nchuti. I'm pleased to present my first project for statistical machine learning. This project was focusing on uh, exploring a regression model and the classification analysis, especially for optimal complexity and generalization and model evaluation. So without further delay, let's dive into key findings. For this project, part one, I start with the regression task. We using data set of observation 225 and two variables x and y, where y is in my response variable, and I was trying to plot them on this scatter plot. As you can see, obviously there is nonlinear relationship between x and y. This suggests that the polynomial model is the best model which can fit this relationship. It means that it is well suitable for to capture this relationship of x and y just because of this nonlinear with this periodic peaks. You can see on this scatter plot. So we continue on a theoretical framework. I decided just to use this polynomial of degree p as my function space, and with this loss function, just to measure the error. Why this? Why I decided to choose this error? I decided to choose this loss just because it penalizes the large error more heavily and the easier optimizations. Above all, it aligns well with regression model. So the way I determined my optimal complexity, I just determine it just as the polynomial degree that minimizes the cross validation error. This ensures the model balance of bias and the variance, and this will help me to prevent both underfitting and overfitting of my model. So I was also trying to plot cross validation error and empirical risk error as a function of my polynomial with that optimal degree I choose p, and I found that there is for this green line for cross validation decrease as the polynomial degree decrease, which so this highlight that the cross validation error will minimize and achieve balance between this underfitting and overfitting model on this diagram. So let's try to compare those models: simple, complex, and optimal model. See which one will fit our data more at best fit. So as you can see, the blue line, this blue dashed line is for simple model. This underfits our model just because it deviates the patterns of my data set. And for a complex one, it is best but overfits my data set, as you can see on this red dashed line. So it is clearly, obviously, my optimal. Highlight the importance of select this optimal of degree 11 with appropriate complexity and robust generalization of this model. So I can say that we can also use test box plot to see. You can see this simplex model on the light upper cone. It underfits our data set. So it is the worst model for this case of regression task. So in summary, I can say the simplest model underfits our data. Optimal is the best one just to choose for lower and consistent test error. That makes it the best performing model due to its balance and the between the complexity and the generalization. So without spending more time on this, let's go on the part two, which is the classification task. In classification task, I use spam data set containing 4,600 observations with 57 features. As you can see on this, they are classified, they are sampled, labeled non-spam and spam. So this plot we show how we are classifying this non-spam and spam, which reasonably balance the classification task. So just to fit this data, I use four models: FAD, ADA, bias, naive bias, and the last one, which is the QDA. So I was trying to fit by using test ELA to fit those models. Where okay, on this diagram, by using comparative by using AOC, it is clearly that FLD and LDA are the best model with high accuracy, as they are closing to the left top corner at this diagram. So I can say they are best, while the naive bias are the worst model on this case of studying for spam data set. So in summary, I can say that LDA and FFD, they perform best with that curve that closer to the top left corner, indicating it's a high accuracy. While QDA, they are less accurate than LDA, but it still performs well. But on naive bias, their worst performance, as you can see, it is too far from the left top corner. Yes, okay. And you can go by using 10 VS code. You can see on also on the on this scatter plot, it is still showing that the bias is the one which which performs worstly. So in summary, I can say this project demonstrates important identifying optimal model, complex for regression task, and the highlight trade-off in the classification model for the spam dataset. By balancing simplicity and performance, we show how statistical machine learning principle can achieve robust, interpretable result, and you come up with a good result. So thank you for your kind attention. See you. Bye.